So this week is primarily going to be on experiments, right? And so this is a type of research design that really is seen as the gold standard of being able to make causal claims that X causes Y. And so, as you see, usually when we think of experiments, we think of this scenario where there is someone who is in a lab coat and they're sort of controlling very specific titration and like scientific spaces, right? So there's a lot of like smaller samples that they're working with, and they're usually not working with people in experiments, right? And so that's really the difficulty of finding cause in criminal justice, is that we are not using people as experiments usually because there are a lot of ethical concerns, right? And so we're moving through the course. And so we talked about theory and knowledge building our first week. Second week, we got through conceptualization, operationalization, population, and sampling. And now we're going into the specifics of type of research method. So how do we set up the design? What is the structure? And so you could think of choice of research method. If the raw materials are conceptualization, operation, population, sampling, then the choice of research method is like processes of how to take those raw materials and make them into something specific. And as we talked about, our choice of research method needs to be separate than our observations, analysis, and application. So those two things need to be separate in order to ensure that we're not influencing the observations that we're trying to instead find out how our research design was very well set up, and then after we've observed those things and collected data in an unbiased way, then we can make analysis and have certain assumptions based off of the type of research method that we're using. So experimentation is an approach to research best suited for explanation and evaluation. So often evaluation, we are trying to understand whether or not a specific intervention actually had an effect, and if it was a positive effect, right? So you'll often see randomized controlled trials of specific types of criminal justice interventions. And so we want to observe the consequences of that intervention and understand whether or not we want to further implement that intervention in the future if it actually was successful in having the outcome, the desired outcome that it wanted. So an experiment is a process of observation that can be carried out in a situation expressly brought about for that purpose. So it's especially suited for hypothesis testing. So if our question is, that poverty causes crime, right? If I have a hypothesis like that, then experiment would be a good space for that. But we also know that defining poverty, defining crime can be difficult. So it's best suited for hypothesis where we really have a good understanding of the concepts and have good operationalization of those things. All right, you saw this earlier in the initial video. Now we're going to see it again. So in order for there to be a relationship that satisfies all of these three components, then we can say it's a cause. So the intervention in this situation, if we're talking about evaluation, needs to come before the outcome. So you can't say that 12-step programs reduce drug use if drug use was lower prior to the intervention, right? That doesn't make any sense. And we need to make sure there's no alternative explanations, like the people who are all given the 12-step program just were selected into it and were volunteers. Then that would be that the people who went to the program we're more interested in recovering. And so that's an alternative variable that we're not accounting for. So we need to make sure that there's no alternative explanations. And usually we do that through randomization, which we'll get into in the next couple of slides. And there needs to be, we need to like physically see observations of these two variables interacting, right? It needs to be in the real world. It can't be from conjecture. So these are the experimental components that we need to make sure of. It's temporal order, again, cause precedes effect via taking a post-test. So the way that we do it in experiments is we take usually a measurement prior to the intervention. So we would, in the case of wondering whether or not 12-step programs are effective in reducing drug use, we would take a drug use observation prior to the intervention. And then we would take it after as well. So once the program's complete. And if an empirical correlation exists, being comparing the pre-test to the post-test, then that means that's a successful experiment. And there needs to be no spurious third variable influencing correlation via post-test comparison. And so this is statistical conclusion validity, and we'll have a whole separate lecture on validity and its influence in causal type research designs. But this last no spurious third variable is really important. And the way that we ensure that is the design of our experiment is supposed to ensure that. So really the research design component is really important. Okay. So experiments control for many threats to validity and causal inference. Experiments ensure that cause precedes effects, and this is basically summarizing the prior slide. And so there are different types of experiments. So overall, an experiment is a study in which an intervention is deliberately introduced to observe its effects. So this is what makes it empirical, is that we're introducing it and we're observing what the effects are in real time, right? A randomized experiment is an experiment in which units are assigned to receive the treatment or an alternative condition by a random process. So this could be numbers generated by a computer, it could be a coin flip, whatever it may be, it has to be random, because then that ensures that we're controlling for any other spurious variables. Then there's quasi-experiment, which will be the next lecture, not this one. An experiment in which units are not assigned to conditions randomly. And then a correlation study is usually something in which there's no experimental design component of that randomization of sort of manipulating our sample. Instead, we're just doing a regression, let's say, and we're trying to see the size and the direction between these variables, but we can't say that X causes Y. We can say when X is this, then Y is likely to be this, right? And so correlation does not equal causation. Alrighty, so just a primary review, independent variables are the cause. So they are the intervention, so the 12-step study, or not having a 12-step study. And so that's what varies in an experimental process, is whether or not the control group or the experimental group get the independent variable. So the control group's not going to get the independent variable, or is going to get some alternative, and the experimental group is going to get the independent variable that we're specifically interested in. And so the dependent variable is the effect that we're considering. So in this example that I used about the 12-step program, it would be drug use. So drug use is the outcome where we expect to see some type of reduction, right? We would hope there's a reduction if we have a planned intervention. And so usually this this might be physical conditions such as behavior, attitudes, feelings, etc. So a classical experiment has variable, time order, measures, and groups. And so usually there's a control group and the experimental group. We have time involved, so we're taking observations prior to the intervention. The intervention happens and then we take observations post intervention. And so time order is involved, and then we have these variables that we're interested, right? And so this involves three major components, which I sort of already summarized, but let's go through them again, is the independent and dependent variable, the effect, and the cause. And then that's pre-testing and post-testing. So we're taking measures of the dependent variable prior, measures of the dependent variable after, and then there's experimental and control groups. So we're sort of manipulating who gets what intervention. Random assignment is the key component of experiments. It's the central feature of a classic experiment. That's why I put these dice here. So think of random assignment when you think of experiments. And so this ensures that our experimental and control groups are statistically equivalent because they both have the same likelihood of being an either or. We reduce any potential outcomes of systematic bias. So there's no selection process. So like in the first video that I did, we talked about the selection of being a football player. There's sort of variables prior to when you join the NFL of why you would get into that. So randomization allows us to reduce those selection biases. So it ensures that the average unit in the treatment group is approximately equivalent to the average unit in another group before the treatment is applied. So essentially these two groups we're trying to make sure that these two groups are the same before they get the intervention, and that the only difference between them after they get the intervention is the intervention itself. And when we're talking about this, we're talking in averages. So the spread of the specific variable that we're looking at might be different in these two groups, but we're measuring the average effect. And so what you want to think of when you want to think of random assignment is all other things are equal. So like we said, we're trying to make sure that the experimental and control group prior to getting the intervention are equal. And so this is a review slide. You've seen this before. Causation, a person's attributes on one variable are expected to cause or encourage a particular variable attribute on another variable, right? And so this is just so you can see the linear direction of independent variable causes dependent variable. So this is a visual of what I was talking about before. So on one side, we have the experimental group, and it's exposed to whatever treatment policy initiative we are testing at a certain point in our research design. They're not exposed prior to our research design, they're exposed at a very specific point that we've defined as researchers. Then the control group is very similar to the experimental group, except that they're not exposed. So we don't give them the intervention. And so you see here that in the experimental and control group, we're measuring the dependent variable. And then the experimental group gets the intervention. And then after the intervention has been fulfilled, whether or not that's a program or any other treatment effect that it could be, then we remeasure the dependent variable. And if they're different, then we can say, all right, the independent variable caused the dependent variable because we made sure that it was randomized and we reduced selection bias. So the only thing we can say is that it was the independent variable. So pre-testing and post-testing is the process that we describe here. When we first measure the dependent variable before the intervention, that's pre-testing, and when we measure it after, that's post-testing. So more specifically, Subjects are initially measured in terms of the dependent variable prior to the association, then they're exposed to the independent variable, then we're remeasuring the dependent variables. And the difference between these two things are the effect that was done upon the dependent variable, and therefore we can attribute it to the independent variable. So something that is an issue is when people know they're in experiments and they understand that they're being looked upon, right? And so sometimes the researcher itself, like us taking measurements, influences how people act. So this is called the Hawthorne effect, and Hawthorne in particular was a researcher, as most things like this are named after researchers, right? And so they were trying to do an experiment with workers, and whether or not improved working conditions influenced their outcomes. And right, so because researchers were observing them working, that actually had an influence, and they were paying attention to that. So measuring the outcomes after that is not considering the effect of the researcher. And so their improvement in employee satisfaction and productivity cannot be solely attributed to the independent variable of better lighting. Instead, it may also be attributed to the presence of the researchers. And so something that medical professionals do to combat the Hawthorne effect is to give a placebo. So we don't want people to know sometimes that they're receiving a treatment or not, because it could influence how they behave, like in the Hawthorne study. So we expose them to a dummy independent variable. So a pill that has nothing in it, right? And so the participants don't know whether or not they're in the control group or not. And so it ensures that the changes in the dependent variable are actually a result of the independent variable and not based on anything psychological. And so sometimes we don't want researchers to influence the studies or the study participants to influence. So we will do something like a double-blind experiment. So experimenters may be more likely to observe improvement amongst people who take or receive the independent variable treatment, right? So in a double-blind experiment, neither the subjects nor the experimenters know which is the experimental and which is the control group. So this really reduces selection and biased observations by the researchers. So when we're selecting subjects for a randomized experiment, we have to, one, determine what our target population is, what's our sample element, what is the larger population that we want to make generalizations about, right? And then we have to select particular members from that group for our experiment. And we have to ensure that the experimental and control groups are as similar as possible. And randomization helps us get towards that. So the conditions that are necessary to do this in the social sciences versus doing it in a lab with like things that we can easily manipulate with our hands, instead we're dealing with people, right? And so we need to get buy-in from the people around us. So staff must accept random assignment and agree to minimize exceptions to random assignment. So if there's an intervention like a 12-step program or a drug reduction program, we need to make sure that the service provider is like, all right, yeah, we want to see how our intervention is working or not working, so we're willing to do randomization. And sometimes people will be pro randomization because there's a limited amount of resources. So sometimes maybe there's a waiting list, so people could get on the waiting list and eventually they'll get the treatment, but not in this particular instance when the observations are getting done. So that's a way to sort of reduce the ethical concerns of it, is to create like type of a waiting list type thing. Case flow must be adequate to produce enough subjects in each group so that statistical tests will be able to detect significant differences in outcome measures, right? So as we talked about in sampling, we need to have enough of a population that we can apply statistical assumptions on it. So if there's like a lag in which there's like the slow process in which people are getting this intervention, then there's going to be, there's more likely to be random external variables that influence, and we're not looking at them. And so the interventions need to be consistently applied to treatment groups and withheld from control groups. So if something we'll talk about later is issues that come up with this, like attrition and diffusion. And consistency. We need equivalence prior to intervention and ability to detect differences in outcome measures after intervention. So the statistical methods for analyzing experiments would be a regression, which would allow us to predict other outcomes as well. And there's some assumptions here that there's linearity to this cause and effect relationship, and that Y is normally distributed. And then there's analysis of variance or covariance that we can use to evaluate the mean differences between two or more treatments. And we can use it to compare more than two treatments at the same time for analysis of variance. And this sort of assesses the amount of variation within group items proportionate to the amount of variation between groups. And so what this means essentially is like we're analyzing the variation between the group in relation to the amount of variation between the two groups. So the variation between the two groups should be larger than the variation within. And after we do the statistical analysis, we'll usually get a P factor, right, which is the statistical significance expressed with probabilities. And so as we talked about, the statistical significance level is different for each type of discipline. Usually ours is 0.1 or 0.01. That's a typo, it should be 0.1 or 0.01. And so this allows us to say, okay, within a certain reasonable doubt, we know that we couldn't have gotten these results randomly, that the way that we set up our sampling and the way that we set up our design ensures that within this range of spaces, the probability of achieving the results we did by chance alone is small, right? And so we know that we're actually finding a relationship, a cause. Because if we know it's not by chance, it represents a real finding between two variables. Alrighty, that was experimental design.